So please press pause on the work you're doing. Look up. Let's review units because that helps you with a lot of free response questions. Starting off, I give you some function. I don't care what the function is, but you'll always hear me say what's the name of the function. In this case, it's probably the rate of the water, adding, subtracting, something like that. And then I also always ask you, given that function, what are the units of that function? So the units of R of t are gallons per minute, which also tells me that the time is going to be in minutes. So if I ask you for R prime of t, I told you guys that there is a way to always get it right. How do I rewrite R prime of t? Right, say it one more time. dr over dt. So we rewrite it as a differential. Why is that helpful? Because what unit goes on top? Gallons per minute, good. And then what unit has to go on bottom? The minutes, the time. And then you just have to be able to do that calculation correctly. Squared. So, your derivative, if you write the notation, it tells you what your units will be. Same thing with the integral. If you write your notation, it tells you what your units will be. How do you find the units of any integral? Multiply what? Yep, the dt by r of t. Other ways that you know it, we've talked about that just being y times x. So take your r of t, which is gallons per minute, and multiply it by time, which is minutes, and they'll cancel, so you're left with gallons. R prime of t times dt. Well, R prime of t was this guy. Gallons per minute squared. And then multiply by minutes. So we're right back to gallons per minute. Just gallons per minute. I took the squared away. You want to be able to do that. Do you notice that a lot of the wordy free response questions, somewhere it always says indicate units of measure. You don't want to lose those points. What am I finding here? Average, the average value of the rate, which is also known as the average rate. Seems weird that we're using an integral for a rate, but it's because the name of this function was rate. All right, so the average rate, well, this part we already know. That's the y, this is the x. This is the tricky part. A and b, what kind of values are those, x's or y's? X's. Well, what happens if you do 1 over x times y times x? You just get your y back again. Every average value is always the same units as what's there, the function that it's talking about. Other ways that you could see it, 1 over minutes times r of t, which was gallons per minute, times dt, which is minute. And then you'll notice, I just do it that way usually. Gallons per minute are back. And that should make sense. The rates, if I tell you that there's a function called temperature, measured in degrees temperature, and I ask you for the average temperature, what would you give me? The temperature. I ask you for the average velocity. What units are you going to give me? Velocity units. An average using an integral, it's always going to be the same as what's here. It's when I ask you for the rate of change of a function. If I ask you for the average rate of change of r of t, now that's not this one. Now I got to do a slope. Okay, so I wanted to review your averages. Average value, can someone raise their hand and tell me the key point? How do we know that we're going to use the average value formula in a word problem? Julie? If it's the same function, I ask you for the average temperature and I give you the temperature. I ask you for the average rate and I give you the rate. That's how you know you're using the integral formula. Good there? Thumbs up if we're good there, please. Any questions before I move on? Good? Okay. All right. FTC2. Some of you do not know that I test this all different ways. So if this is the integral of the derivative, what's the antiderivative? That would be the first step. What is it? F of x. And then to evaluate the integral, you would do f of b minus f of a. So you'll have a bunch of questions where I ask you for f of b. And how do you find f of b? F of a plus the integral from a to b of f prime of x dx. What's the words that I use for this? To find a final value, you use an initial plus displacement. You have no idea how much I ask this question. So on your 5.4 quiz, Lottie, which number was it? 5. That was in your 5.4 quiz. Most of you did not get any points for that one. Look at it really carefully. I gave you a derivative. I gave you a value. Then I asked you for another value. Okay? You have to be able to use FTC both ways. The other way that I've seen it get tested, I tell you, this is my question, find. And I've seen that be used too. I gave you that on one of the questions. I think I asked you for like S of 4 minus S of sub 2 or something weird like that. All right, let's look at the multiple choice questions real quick. So I'll tell you right now, most of you probably got this one wrong. You got the right answer, but if I looked at your work would be incorrect. Let's walk through. It's asking you for a maximum value. What inside of the problem is extremely important? Oh, I know the function. What's the part that most of you probably ignored? Look at your paper. Did you evaluate your endpoints? Did you look at your endpoints? Because I'm guessing you're asked to find a max of f, which means whose sign chart am I making? F prime sign chart, which is the function you're given. Your sign chart from 0 to 2 had 2 intercepts. This one was a 1.4 something. 6. One more. 5, thank you. 0, 0. This was plus, this was minus, this was plus. So, left endpoint is a minimum. There's my max. There's a min. There's another max. So this is a max, and this is a max. So I would be looking for the fact that you're comparing them. So what do I have to find? If I want to maximize f, what do I have to compare? The y values. So what's the function that I'm putting the x values into? F or f prime? F. How do I know that? Because that's whose max I want. So f of 1.465 and f of 2 is what I would have to compare. How do you find an ending value given the derivative? Antiderivative, but what's tricky about an antiderivative? I can't just do an antiderivative. That's what I keep trying to get across. If I ask you for the derivative at 5, you're going to take the derivative, substitute in 5. If I ask you for f of 5, but I give you f prime, how do you take the integral? What's missing? Why can't you just take an integral? You need a lower limit and an upper limit. So what if I asked you to take the integral from 0 to 5? Does that give me f of 5? Considering we just went over this one frame ago. No, what are you missing? An initial. Every single time you use an integral, you should be thinking, do I need an initial value? So if I want to find an ending value, how do I find it? Won't be the integral, you're going to get it wrong. You need an initial value. What's missing from the problem, though? They don't give it to you. Where would your mind think to take your integral if you're trying to get to here? From where to where? From 0, right? So most of you will do this. But what are you missing? If I'm starting from 0, what do I need here? The initial at 0. The initial at 0. So then the question is, why didn't they give it to you? If these were both 5, they're both the same, right? Because they're both f of 0. If they're -2, if they're 20, if they're pi, if they're 1.2, does this part matter? No. This is what's going to tell you which one's bigger or smaller, correct? You can use that just graphically. So the graph of this looked like, I believe it went up, down, and then hooked just a little bit from 0 to 2. Some of you don't chop off your windows. I would. If it asked you from 0 to 2, I would only show 0 to 2. So graphically speaking, this integral is whatever f of 0 is plus this part. Versus this integral, f of 2, would be from the start, all of this minus this plus this piece. So can you, just by looking at it, tell which one's bigger or smaller? Yeah, so I actually wouldn't even have to give you necessarily the function. I could give you just a graph of it, re-ask the same question. So this one does end up being the max. I know most of you wrote that, but you didn't write it for the right reasons. You didn't analyze your endpoints. And I really need you to understand that. If I gave you the function and changed the graph this way, and now that was 2, your answer would have been wrong. Okay? Your answer would have been incorrect because now at 2, the net signed area is bigger. I can't stress enough that when you use your integral, most of you don't use it properly. An integral from 0 to 2, it does not find f of 2. An integral from 1 to 5 does not find f of 5. It finds you the change from 1 to 5. It finds you the change from 0 to 2. It is extremely confusing. Having to remember that extra piece is confusing. So then I gave you this guy. This one you just had to make sure you're subtracting. Most people will get it wrong because you don't notice that you're going and losing. So let me just at least write the notation with a little bit of time. So it's asking you for gallons at 6 would be equal to the gallons at 0 plus the integral from 0 to 6 of 9 sine of root of t plus 1. So that should get you the right answer. Number 3, a lot of you have a question for this, so let me change the question. At noon, I'm at school. At 1 o'clock, I went over to Lottie's house. From 1 o'clock, I decided I'm going to run 5 miles. What's my total distance at time equal to 1 o'clock, or from time equal to 1 o'clock? The 5 miles. Does it matter that from school to Lottie's house, that distance that I traveled, does that matter? No. So let's look at this question one more time. For a time greater than or equal to 0, the position at time equal to 0 is at 1. I am standing at the position of 1. Then I'm going to go do all this motion. And then it's going to ask me from my position at 1, how much distance did I travel? So a lot of people had these different notations. Give me a moment. You guys had 1 plus integral from 0 to 4. You had 1 plus the integral from 0 to 4 of this. And then you had just the integral from 0 to 4 of this.
Class of 2014, the Guaranteed Access Grant online FAFSA application and free Montgomery College online application have March 1 deadline. Please visit the Career Center for additional information.
This one gives you the position at 4. That one's the one that would ask you, where are you at time equal to 4? This one gives you nothing that's really helpful. It gives you the 1 plus the total distance from 0 to 4. This one is the answer, total distance. This one just gives me displacement. Slight change in notation and all of a sudden it's wrong. Okay? What was the last one? Was the last one tricky? Average rate. I gave you a rate. Now I want its own average, so just making sure that you remember notation. There you go. All of those you should also be able to do units. Okay? Homework is whatever's on the calendar, whatever was on the flip chart, I can't remember anymore. But you should have everything you need. Tomorrow is not your quiz, right? No. Okay. Review tomorrow. All right. See you guys tomorrow. Any issues, questions?